In one end of a piece of elastic is attached to a door frame and the other end hangs freely. When the ball's pulled down a small distance and released, it just going to oscillate so backwards and forwards like so. Okay, and depth can get down to there, and it can go up to there. So part A. Oh, that's the model of it. So the greatest and least depths. Well, greatest depth of cos of 500t. Cos can go between 1 and -1. It can't do any more than that. So the greatest depth is going to be greatest d equals 100 plus 10. When that is cos 500t equals 1, which equals, that is 110, and the least depth will be when it's 100, and this bit's cos 500t is -1, so that is be -10, which equals 90. And the time at which it first reaches its highest position will be here, because that is the depth, and that's 90. And so I need to find out, when does it equal -1? So this is part B. Cos of 500t must be -1, and so 500t will be cos to the -1 of -1, and so 500t, that's -1, cos there, cos that axis, that's -100, that's 180 degrees, and so t equals 180 divided by 500, which equals 0.36. C, the time taken to complete a whole oscillation. Well, if it takes 0.3 seconds to get up there, it's actually going to take 0.3 seconds to get down there. So the whole time will be 0.72. You could have worked it out when cos t was 1 and got a second value and find out from there, but it's going to be 0.72. D, the proportion of the time during a complete oscillation for which the depth is less than 99, so that's 110 down there, so its depth is less than 99, so that's 100 bang in the middle, 99 is just a bit above there, so it's going to be a bit less than 50%, because 50% of it would be below 100, to be below depth to be less than 99, that is anywhere in this bit here, so obviously it's going to be a little bit less than 0.5. Best thing to do, I think, now is to draw a little picture of it so you can see what's going on. If I look at the graph I've got here is 100, there is 90, and here is 110, and it's going to oscillate between those. It's just going to, basically that's what it's doing. Ooh. Goes, etc. And we know that going from there to there is 0.72 seconds, and I've got to work out how long is it below 9. That's 100 there. If I do it in red, that's 99 there, say, and I've got to work out that bit from there to there and work out what proportion that is, that distance there, of the whole time. So I've got to find that. So I've got to find these two particular values, and that is when the depth equals 99. So first stuff I'm going to have to do is find when the depth, which is 100 plus 10 cos 500t, when does that equal 99? So solve that, take away 100 on both sides, 10 cos 500t equals -1, so cos of 500t equals minus 0.1, so 500t equals cos to the -1 of -0.1. I'm going to bring it across here a little bit, so 500t equals cos to the -1 0.1 is of -0.1 is 95.739, and that's going to be plus 360n, or it's going to be minus that, minus 95.739 plus 360n. Reason for that is unit circle. this is my angle here, there's cos there because this one's sine, and we want to be minus 0.1, so minus 0.1, or cos is this accent there, that's minus 0.1, and so it's either going to be this angle here, which is negative 95, but it could be this one here, which is positive 95.73. So that's why it's like that. Divide both sides by 500, so t equals 0.191478 plus 360 divided by 500 is 0.72n, or minus 0.19147 plus 0.72n. And so t equals, and I want the first two it can be, so it's 0.191478, or it's when n's 1 here, and we get 0.52852. And so therefore the time under 99 equals the gap between here and here, so that's 0.52852 minus 0.191478, and that equals 0.33704, and therefore proportion of time equals 0.33704 divided by the total time, which is 0.72 for one cycle, and that equals 0.4681, which equals 46.8% is a proportion of time. And I hope that's clear enough. That's done.